them to do the integrals. So on that note, how would I do this integral? I already got the half out here, but what can I put? Half. You can put another half with it, right? And what's this turn into? You know what? Before I put that half there, I should just write down that identity. What is it? I'll just repeat it. It's what? 1/2 plus 1/2 cosine of. Now it's in theta, so I'll write 2 theta. You agree? But how would you do this integral? Any suggestions?
Take out the 1/2.
That's a good idea. Take out the half. Back out a half. Well, what's a half times a half?
4.
Alright. Bad idea, I like it. Now one of these involves a u sub. That doesn't. What's the integral of 1? That's just theta, right? Alright, everyone, this guy here involves a u sub. Right? Do it equal 2 theta. The integral of cosine becomes a sine, right? So in here you get theta plus 1/2 sine of 2 theta. Get that out of the way, put a parentheses here. That 1/4 is still out in front. Is everyone okay with that? That's via u sub. You can explore it. Let u equal 2 theta. You get that 1/2 to pop up, so the sine of u becoming this. And what's the limits? 0 to 5 or 6. So what would be the answer to this problem? Just doing this integral here. 1/4 theta, 0 to 5 or 6. I get 1/4 of pi over 6 plus, what's 2 times pi over 6?
Pi over 3.
Pi over 3. What's the sine of pi over 3?
Root 3 over 2.
Square root of 3 over 2. So when I have 1/2 times sine of this would be pi over 3, and I get square root of 3 over 2. Now I gotta plug in the what? The zeros. Well, good news when you plug in zeros. Now, what's a 0 here? And what's the sine of 0?
0.
I like that. So what does this all turn into? Well, I still got to distribute that 1/4 of that. Unless you want to leave it like that. We can write it a little better than that, right, Owen? What's the answer to this problem? 1/4 times a pi over 6 plus square root of 3 over 4. I mean, that's fine. Unless you want to distribute the 1/4. What's that distributed?
Pi over 24 plus root 3 over 16.
Good job. Pi over 24 plus root 3 over 16. I haven't looked at Bob, how Bob wrote that. That would be equal to that. Everyone okay with that? Nice. Good deal. This is polar coordinates. Some of the images in the book, they showed you the graph, so all you have to do is look at the graph to determine the limits of integration. But let's get to the heart of the matter. What's the challenging problems? When we don't know the limits, and you and I got to somehow do that one loop. There you go. Let's do one of those. Like that's the only thing we're concerned with. That one. You know how to deal with these integrals. Just use that nice power reducing identity. We're looking at what about? I got to find the area. I'm going to a problem when this is like number 17. Find the area, or 19. Find the area of, or they said enclosed by. Find the area of the region enclosed by one loop of the curve. I want to use the exact words. Find the area enclosed by one loop of the curve. Find the area enclosed by one loop of the curve. Which one is this like? This is like number 17 on the book. And 10.4. 19. Even number 8. If number 8 had an image. I don't want to do 8 because number 8 is too easy. They showed the graph already. Yeah, they showed it for us. We know the challenges when we got to make the graphs. All right. So the one I have here, Owen, can you find the exact, do they say exact? Yeah. It's got to be the exact, and we'll find it for. Let's see. Here, R equals sine of 3 theta. We gotta find the area enclosed by one loop of the curve R equals sine of 3 theta. Number 19 had sine of 4 theta. This problem's a piece of cake. 1/2 out here, what's getting squared? See what I mean? Isn't that area? What's the tough part though? You bet. Look, you know the formula, right? It comes from area of a sector. Piece of cake. I put the R in there, I squared. I put a 1/2 out here. This will give me the area. What's this? Right? How far? What are those limits that form that one loop? So what I have to do is use the tools, the methods we did back in 10.3. So can you help me sketch this, baby? I'll just make a what? Full table. We need theta and R. And look at this, the polar curve. What forms one loop? If it helps, I'm going to look at this again in Cartesian coordinates. That's why I go way over here. The only reason I keep crossing way over here across the other side of the board, I didn't want you to think this is the polar curve. I'm just exploring that relationship in Cartesian coordinates. It helps me see the one loop. So in Cartesian coordinates, what would this look like? This relationship. That's what I call it. I call it the relationship. What is this relationship in Cartesian coordinates? And after a while, you see a pattern of these. That's the best part. R equals sine of 3 theta. Now, we were just talking about this. What's the 1 period?
2 pi.
2 pi over what? So I'm going to make 4 tick marks. Tick, tock, and put a 2 pi over 3. Now what's the sine curve do? The cosine started up here in the air and ended in the air. What's the sine curve do?
Starts at 0.
Starts at the origin, swings around, hits the origin again. I'm not the origin, but the x-axis. Then it comes back down and hits here, right? That's the sine curve. How high does this thing get?
1.
Gets up to 1 and gets down to?
-1.
-1. And we're saying this is R, this is theta. This is that relationship in Cartesian. This isn't the polar curve. But this will help us determine the one loop. How many know where one loop will be? From there to there. I guarantee it, because there's what's happening at the pole, and this is what's going to happen at the pole. You know? This is given away to me. The only thing is I got to figure out that tick mark.
Pi over 3.
Excellent. Half of 2 pi over 3 is? Everyone, I know the limits now. Just from this. I didn't even sketch the one loop, I didn't sketch the one polar curve. It's because this is taken on a 0, that's at the pole, and there's another 0 of R, right? At the pole. That's when R keeps hitting 0. That would make the one loop. So I know this is going to be from what? 0 to pi over 3. It will be. But let's do this anyways. It's just cool to look at this. 0, what was between 0 and pi over 3? Ooh, thank you. I'll put that here. 0 pi over 6, and then pi over 3. It was 0, this was 0. What was going on at pi over 6? Pi over 6, I'll label it right here when that's pi over 6. It got up to a 1. Cool. And there's your one loop. One loop. Can you help me sketch it though? Okay, I know we were talking about it before, but if we didn't want to pull out the calculator, how would this graph do? Start at the 0, 0. And then let's move to an angle pi over 6. What's pi over 6 in degrees? So go out 30 degrees, everyone, but how far you got to swing away from the pole? Swing a distance of 1, so here's about 30 degrees. Pi over 6. Swing about a distance of 1 away from the pole, and then what happens?
And then it comes back.
Swing back. Just like 0, 0. 0, 0. And here's the one loop. One loop. 0 to pi over 3.
We still need time.
You still gotta work the problem. I don't know what you think. I think that's the hardest part of the problem. I think we'll be fine. We're gonna use the what? Which one of these? We'll use that one, right? Cool. Hey, can we talk about like shortcuts and patterns? Have you noticed something? What's that number right there? Well, not only is it odd, it's a 3. And what's that number right there? A 3. Isn't that interesting? Guess what would have happened if that was a 2? Guess what would be, that'd be power 2. I'm serious. Now, I'm not going to go down to sine of theta because that's a circle. That's a totally different story, but I'm going to keep going. What if that was sine of 4 theta? Pi over 4. I'm serious. If you can find this helpful, especially in a test, go for do it. Sine of 5 theta. What do you think this would be? Pi over 5. You could play around with it. Do it all day. You would notice the same pattern. Okay, now be curious. Does that work with cosines too? Actually, it does. Actually, it does. Because cosines like sine. What is its period? 2 pi, right? You'll notice the same difference, okay? But I have to be careful. Does that work for all integers? Hold up, because you get down to like a sine of 1 theta. Now that graph doesn't have all those petals anymore. It turns into just a circle, okay? And when we did the hard part, at least in my eyes, we did the hard part. You ready to do the trig identity? Is everyone okay with that? Nice. There's your one loop. Only that one loop right there. One loop. Going whoop, and back here. That formed that one loop. 0 to pi over 3. We need the trig identity. What is it? Well, I'm going to write it out carefully first. It's 1/2, right? Is it plus or minus? Minus, thank you. Minus another 1/2. Don't be like the professor. Sine or cosine? It's cosine. It's cosine. Now, this is new. I used to put 2t or 2 theta. What's this at? This has a 3 theta in there. Guess what I'll put here? I hope this isn't too confusing to you. Look what I just wrote. I hope you don't find this too confusing. I just wrote 6 theta. And you go, why? Because what do I have to do? 2 times whatever t was. What was in there? What was that t? A 3 theta. Does everyone follow that? Just so you're comfortable with this. What if that was 4 theta? You would have put what there? 8 theta. You got it. And what if that said 5 theta? What would you put here? 10 theta. You got it. Let me put my d theta down. I don't think you're going to have any trouble with this. But we will find, everyone, let's find the exact area. So if we put this into our TI-84 for TI-83, it's going to put it in decimal form. Let's get the exact area. Suggestions. Do you want to factor out the half? It's up to you. Okay, I will do. Let's factor out the half. Okay. 1 minus cosine of 6 theta. We do know we expect the u sub right there. That'll be a u sub. That's an easy integral. What's integral 1?
Just theta.
Just theta. 1/4. I'll put my brackets so I don't forget to distribute. Here comes the u sub. But we've seen this over and over and over again. We don't have to write out the u sub now.
1/6.
This becomes a negative sine of 6 theta. And what do you divide by?
1/6.
1/6. That's via a u sub. That is by the u sub method. We've seen it over and over and over again. That's what happens. Cool. And what we got plugged in here? 0 and.
Pi over 3.
And good news, everyone, don't forget, sine of 0 is 0. And when you plug in a 0, you get 0. So this is going to be easy to deal with. The hard part's over. If you think plugging that in is going to be tough, it isn't. Expect a bunch of zeros. Except for this. When you put a pi over 3, that stays what? So the answer's not going to be 0. We can see there's some area here. Get the area of one loop. We can tell there's some area. You ready to do it? What's pi over 3 plugged in here? So I'll just plot an arrow and go like this. Look at the answer. 1/4 bracket 0 minus, what's sine of 2 pi? 0. Minus, now plug in the zeros. 0 minus 0. Right? But right here, that very first one had to be the what? The pi over 3. I didn't want you to think the answer is going to be 0. When I plug a pi over 3 into that theta, it just stays what? Pi over 3. So I get 1/4 of pi over 3, subtract, you plug a pi over 3 in here, you get 1/6 of 0. Then you plug in the zeros, you get 0, 0, so what's this final answer?
Times 1/4.
What's 1/4 of pi over 3? Pi over 12. Ooh. What do y'all think? Awesome, Dave.
If you were asked to say find the area of 2 loops or 3 loops, do you just take the answer and multiply by
You got it. They don't ask that, but I love it. If they ask you get 3 loops, you're like 3 times that. Because they are all symmetrical. All those loops, you can look at with it looks better with the technology. But they'll all be symmetrical if they ask that. Me on a test, I just asked for 1 loop. Hey, we're gonna do another one of these. Can we talk about patterns again now? Sine of 3 theta. What did it end up being? Pi over 3. Now look at this answer. This was pi over what? 12, which is 3 times what is 12?
4.
Okay. Do you notice that? We want to see if that always happens too? Where you say this final answer will just be what? 1/4 of pi over a 3rd. You want to check that out? Let's do it. Let's do another one. Let's do one cosine. You ready? How about cosine 2 theta? Didn't we have that up there earlier? Something like that. I don't think I had a 4 in front. We'll just leave a 1. All right, let's do a 1. And let's see if that happens. Sound cool? This one will go quick. What's that in Cartesian? See, now you're getting faster. What is cosine 2 theta in Cartesian? In case, I just want to find the limits of integration. Tick tock, tick tock. What's 2 pi divided 2? Pi. So this is what? Pi over 2. This would be negative pi over what? 4? Pi over 4. Starts here, gets down here, comes up here. We know about the cosine curve. Whoop, 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 whoop. This graph goes back down here if you want to know. Anybody know what we can do for limits of integration? Give me some options. What would form one loop? That would work. And when she hasn't even done this, she already knows what would form one loop. I want you to see this. You can go from negative pi over 4 to pi over 4. That should form one loop. How does Kate know that? Because she noticed it's going to hit the pole here and it's going to hit the pole there again. This is why I want you to concentrate on. When we do our polar graph, it's going to be at the pole there, it's going to be at the pole there. What else could I have done? I could do pi over 4 to, what's that? Pi over 4, but I'll use yours. All right, negative pi over 4 to pi over 4. I'll put the half in front. And what do I gotta, find my error. I'm worried this happens on a test. I've seen this before. What's messed up? And I'll give you a question, but what did I screw up? Don't forget to square that, right? Very good, I'll put it here. Okay, Connor.
So, like, on a test, can we just show you that?
Heck yeah.
Instead of doing, like, all.
Heck yeah.
Okay.
I think that's great. Or you might even say, hey, I knew this in my head. I knew mentally that these would be the limits.
Okay.
You know, I love it. Now I'll go in here and write it, but we're like, what would have happened for that one loop? Bless you. This is what would have happened, then at 0 got to a what, a 1? I think it's awesome.
Thank you.
Hey, but didn't we have a shortcut that could have worked? So I'm gonna write this. Kate, you were right, this is perfect, it's gonna work great. It's gonna work great, but didn't we have a shortcut we were talking about? Where I said, no matter what, sine or cosine, I could do what? 0, 2, what's pi over that number?
2.
So I wanna make sure everyone sees this. I also could have started the problem like this. Look what I did.
It's the same distance, isn't it?
Because it's the same distance. So I wanted to point out that pattern I was talking about still works with the cosine. As long as this number is higher than a 1. When it forms all the petals, look. Pi over the 2, see it? That's exactly giving you the same answer. And plus, students like this sometimes because you put a negative pi over 4 that messes up your final answer. True? Get a 0 in there, it's a lot easier to work with.
So we have a variety of different limits that we can use.
A variety, a total variety. Look on this graph where it went from. If it went from 0 to pi over 2, it was funny. It went from here to that area and that area. But do you agree these two areas add up to that? You see the symmetry, very good. And that's what's happening here. Same thing with that polar graph, which would have done what? It would have went, yeah, and then back like that. And when there's this one loop we're talking about. For this one, but you could have done this. Cool. Okay, let's do all the math. I bet you can predict the answer. What's 1/4 the power of 2? What's 1/4 the power of 2?
5 or 8.
Let's see what we get. Okay, let's play it out. What's the trig dynamic? 1/2, take it slow. 1/2 is a plus or minus. Plus 1/2 is it sine or cosine? Cosine, and what do I do with that 2 theta? It's like I'm multiply that 2 to it. You get 4 theta. My limits are 0 to power 2. Now, what are your suggestions? Back up to 1/2? 1/4. 0 to power 4. We're rolling. 1 plus cosine 4 theta d theta. All right. What's that interval? I get 1/4. I'll put a big bracket. Theta plus, what's this become? Sine of 4 theta over a 4. Oh, go ahead. Oh, yeah, thank you so much. I'm going to keep that power 2. Thank you so much. I want to keep the power 2 like we had before. I thought this would be easier to work than that. But Kate, this would have worked. But he's right, I got to make sure I keep it 0 to power 2. 0 to power 2. 0 to power 2. Unless, here's something else. I don't want to confuse anybody. If I went 0 to power of 4, I could do that, but I'd have to eliminate the half. Does that make sense? And because of the symmetry, couldn't I do that? If I just put half that limit, 0 to power 4, and just remove the what? The half. Because of the symmetry, right? Same thing's happening with those loops. But I'll leave it. I'll leave it. Hey, what do you get out of this? What do you get out of that? 1/4 power 2 plus, put a 0 in there, what's the sign of 0? 0 minus, now put your zeros in there. So what's that answer? Just like we thought, pi over what? Hey Connor, that's the only thing I don't want someone to do on the tests is they get the problem, they just look, they just go, pi root. 1/4 of that, I know. Just show some work. You know what's coming up though, right? I like when you all see patterns. I don't like this being like hidden from you. You can really see that. This just keeps happening with this. Hey, one more of these. So we do like, I'm gonna pick one near the end where 2 graphs meet each other, and then you and I gotta figure out where the 2 polar curves meet each other. I'm gonna draw them for you. When can you find the area enclosed by? Now this is how the author wrote this. Last problem. Can you find the exact area of the region that lies inside the first curve and outside the second curve? Here's the first curve. R equal to 2 cosine theta. Oh, by the way, I'm taking number 23. This is in section 10.4. That's the first curve, and this is the second curve. R equals 1. Okay. So I'll get this out of the way. We won't need that.